Number 12, find all zeros of the polynomial function. And we're just going to use the rational zero theorem. So I have 5x to the fourth minus 84x to the third plus 218x squared plus 372x plus 65. And what if I said factor that? Well, it would be impossible. But it does, in fact, factor. And I will show you those factors. And we're going to use synthetic division to find them. I'm going to look at all of my powers to make sure they're all there. I've got a 4, a 3, a 2, a 1, and a none. So perfect. 5, negative 84, positive 218, 372, and 65. And I have a feeling we're going to need our calculators on this. I've got to find the factors, and these are the plus or minus factors, of 65 over 5. The good news is 65 doesn't have that many factors. It's going to be plus or minus 1, plus or minus 5, plus or minus 13, plus or minus 65. We have to put all of those over plus or minus 1 and plus or minus 5. When we put them over 1, we get plus or minus 1, plus or minus 5, plus or minus 13, plus or minus 65. But now we have to put them over 5, plus or minus 1/5, plus or minus 5 over 5, which is 1, so we don't need to list that one. Then plus or minus 13 over 5, and plus or minus 65 over 5, which is actually 13, so we don't need that one either. But we do have 2, 4, 6, 8, 10, 12 possibilities. Okay, now remember, each time we divide synthetically, we'll reduce the power of the polynomial and we'll also reduce the number of factors that are possible. So let's start in the middle. Let's start, with 5 or 13. Definitely don't want to start with fractions. So I'm going to go with 5 first. I'm going to drop the 5. 5 times 5 is 25. Negative 84 plus 25 is negative 59. 5 times negative 59 is negative 295. So 218 minus 295 is negative 77. 5 times negative 77 is negative 385. 372 minus 385 is negative 13, and 5 times negative 13 is negative 65. We have found our first zero. So now our polynomial has been reduced by 1 degree. So we're now down to 5x cubed minus 59x squared minus 77x minus 13. So I'm going to list my new possible factors. And those are going to be the factors of 13 over the factors of 5. So not as many. Plus or minus 1 plus or minus 13 over plus or minus 1 plus or minus 5. So over 1, it'll be plus or minus 1 plus or minus 13. And then over 5, it's going to be plus or minus 1/5 and plus or minus 13/5. So I start in the middle, somewhere in here, and probably would try all 4 of those, but before I would try the fractions. So I'm going to go with 13. And I'm going to take these new coefficients, 5, negative 59, negative 77, negative 13. I'm going to drop my 5, and I'm going to multiply. 13 times 5 is 65. Negative 59 plus 65 is positive 6. 13 times 6, 78. I add them together. I get a positive 1. I multiply 13 times 1. I get a 13. I've found my second zero. So 5 is a 0 and 13 is a 0. And remember, the maximum number we'll find is 4. So remember, we're looking for 4. We don't know how many will be real, how many will be rational, or how many will be irrational. But we already have 2 of the 4. And I've progressed, and I have my exponents down to x squared plus 6x plus 1 equals 0. Now this will also factor. Okay, 5x squared plus 6x plus 1 will factor. I'm going to show you the factoring, and then we'll just go ahead and do the rest by synthetic division to see how we could also do it that way. I've got a 5x squared plus a 6x plus a 1. My AC is 5, positive, has to add to 6. Well, that's a 1 and a 5. So I'm going to write 5x squared plus 1x plus 5x plus 1. So for term, we'll use grouping, first pair, last pair. Drop that plus all the way down. I'm going to take out the common factor x. I get a 5x plus 1. And here they don't have a common factor, but it actually is a 1. And I'll get a 5x plus 1 there. I have a common binomial. Factor to the front. 5x plus 1 times x plus 1. Now these, if I set them equal to 0, 5x plus 1 equals 0. 5x is negative 1. X is negative 1/5. X plus 1 equals 0. X is negative 1. These are the 2 missing zeros. So we know that they are 5, 13, negative 1/5, and negative 1. 5, 13, negative 1/5, and negative 1. So those are my zeros. They're all real, so this polynomial function would cross the x-axis 4 times. Now let's say, you didn't notice it would factor. So we're down to 5x squared plus 6x plus 1 equals 0. We've got to do the factors of 1 over the factors of 5. And of course, we have to look at both the plus and the minus. Well, that's just a plus and minus 1 over plus or minus 1 plus or minus 5. So that gives me plus or minus 1 over 1, which is 1, and plus or minus 1/5. So I have the option to synthetic divide by any of these. And of course, I'm going to pick these integers first. So first I'll try the 1. I've got a 5, a 6, and a 1. Drop my 5. 1 times 5 is 5. Add, I get 11. 1 times 11 is 11. Add, I get 12. Not a 0, but we do know this. If we put 1 in the function, we would get a 12. But it's not a 0, so I got to keep going. Negative 1, 5, 6, and 1. So drop my 5. Negative 1 times 5 is negative 5. Add, I get a 1. Negative 1 times 1 is negative 1. Add, I get a 0. I have found my third 0. So there's that negative 1 that we got when we factored. Now the good news is, look at this one. I'm down, this was an x squared. I'm down to an x to the 1 plus 1. So 5x plus 1 is 0. That would be 5x equals negative 1. X equals negative 1/5. And there's that fourth 0 that happens to be a fraction. So that's our final answer. 5, 13, negative 1/5, and negative 1. So x is 5, x is 13, x is negative 1/5, and x is 1. Now I'm going to show you how this polynomial, the original one, would have factored. I'm going to move these to where they're equal to 0. So x minus 5 is 0, x minus 13 is 0, x plus 1/5 is 0, and x equals 1. So x minus 5 is a factor, x minus 13 is a factor. Now we wouldn't normally put x plus 1/5. What I would do there is I would multiply everything by 5 to get 5x plus 1 equals 0. So there's my factor, 5x plus 1. And then my last factor is x minus 1. So if you want to take the time to multiply that out, or put it into Mathway and see what you get when those 4 things are multiplied. Not the equal 0, but the 4 factors. And you should come out to this original function.